Hey, welcome back. This is Calc 2. Today we're going to do inverse trig functions, in particular doing the integrals of them. So recall the derivatives of these things. And let's say we have, I don't know, f of x is equal to sine x, and then we're looking for the derivative of sine inverse, right? So f inverse of x is sine inverse of x. So again, from the composition rules, we could say f inverse of x is equal to x, and then we can differentiate implicitly. So we get f prime of f inverse of x times the derivative of the guts, which in this case is f inverse of x, which is what we're looking for. So times the derivative of f inverse equals the derivative of x is just 1. Right? And then we could solve for this derivative of inverse sine. Right? So divide both sides, and we get the derivative of f inverse is equal to 1 all over the derivative of f evaluated at f inverse of x. Okay, so we could fill in the blanks, so to speak. First off, the derivative of f prime of x, of course, is cosine x. We know that from Calc 1. So we have, the derivative basically of sine inverse, which is what this stands for. We could rewrite it as the derivative with respect to x of sine inverse of x is equal to 1 all over f prime is cosine of f inverse is sine inverse of x. Okay. And in an appropriate interval, we can use triangles to kind of figure out what that expression means, cosine of sine inverse of x. So the thing going into sine inverse is the ratio of sides of a right triangle. So if you look at the sine inverse, this x part is the ratio of sides of a right triangle. And you can think of x as x over 1. Okay, so sine is opposite over hypotenuse, right? So if you look at a right triangle, the opposite of this angle here, which is sine inverse of x, is going to be opposite x all over hypotenuse is 1, and then you could use Pythagorean theorem to get that third side, right? So it's x squared plus the third side, the b squared equals 1 squared. B squared is 1 minus x squared. And then b is kind of plus or minus, but for us, we'll go with 1 minus x squared. Okay, so 1 minus x squared for the third side. And then we could do a substitution for the cosine of sine inverse, which is basically the cosine of this angle, right? So cosine is adjacent over hypotenuse. So this will be 1 all over adjacent is square root of 1 minus x squared all over 1. Okay, and that turns out then to be the derivative of sine inverse, 1 over square root 1 minus x squared. So I expected you to have that memorized in Calc 1. The derivative of sine inverse of x is 1 all over the square root 1 minus x squared, just like I expect you to have memorized the derivative of tan inverse, right? If you remember, let's put it in terms of some expression of x, u. Via the chain rule, we'll have 1 all over 1 plus u squared times the derivative of u with respect to x. Right? That's just times the guts, basically. Okay, I expect you to have those memorized. So if you know those, then you can kind of get the integrals of the day that we are going to be working with today, but kind of. Okay, we want a more general version of those integrals. And I'll expect these first two memorized. So you can make some note cards or do whatever you have to do to get it done. I'm in favor of getting a big sketch pad and just kind of mapping it all out like you would do kind of a decision tree with a computer program. We'll probably do that in the honors section, but everybody else kind of left to their own devices. integral formulas. The first one you need memorized is the sine inverse version. So instead of 1 minus x squared, we have a squared minus u squared. Okay. And that will turn out to be sine inverse of u all over a plus c. The second one you need memorized is the tan inverse version. You can look up the other versions. Usually they're just negatives. So if you have a negative du over a square root a squared minus u squared, that'll be cosine inverse. But you can kind of get around it by just putting negative sine inverse at the end of the day, I guess. So you don't even need these other formulas, but they're in the book. Okay, so if you need a formula that's not one of these two that I have you memorize, just look it up. Okay, so this one is 1 all over a tan inverse of u all over a plus c. So these two guys, though, you have to know. They have to be memorized just to get you through the day. It's kind of like not knowing what 1 plus 1 is. Okay, so memorize these. You have 9 plus 5 memorized, 14. Right? The one you don't have to have memorized is the secant inverse. So du all over u square root of u squared minus a squared. It's a little bit like tan inverse, so it'll be 1 all over a secant inverse of something over a. You have to put some absolute values in here, so that's the difference between this and the tan version. Okay, so there's that. Let's dive right in, and take a look at some of the exercises that we have in the book. Okay, so let's look at number 2. And as usual, I'm using an older edition of the book, so these may not correspond, but they're all the same. They're just variations on a theme. Let's look at 1 minus 4x squared. So we want to put it in sort of one of those forms, one of these 3 forms. It looks like it's the sine inverse version because it has a squared minus u squared inside the root. Okay. So it looks like and you may even want to note what a is if you're really a is just 1, right? So this 1 squared is 1, and then we're going to let u be 2x. If that's not obvious, look, I'll rewrite this. It's dx all over the square root of 1 minus 2x squared, right? Because 2x squared is 4x squared, so u has to be that 2x. And now you do have to kind of worry about the differential du. We have a constant floating about that we have to kind of equalize with, so we have du over 2. And once we do that, we should be able to just use the formula to integrate it. So we have the integral of 1 all over the square root of 1 minus u squared times dx, which is now du over 2. We can factor out 1/2. And we have it in the form of the sine inverse, where in this case the a value, sometimes it's better just to wait to identify the a value. The a value is 1, so we have 1/2 times sine inverse of u all over a plus c, and then back sub 1/2 sine inverse of u, which is 2x, over 1, which is just 2x, plus c. Okay, let's keep on moving, right? Let's look at number 11. Okay. So the integral of t all over t squared plus 25 dt. And let's go ahead and kind of, so what form is it, right? It's clearly the second form. It's the only form that has a plus in it. So we can, and that should be a t to the 4th, not a t squared, sorry. So our u sub, to put it in that form, you kind of want to find a u squared plus a squared, right? Now, it looks like the a is going to be 5. Maybe you're kind of questioning what u should be, but if you rewrite it as something squared, it usually tells you what your u is. So in this case, u looks like it's going to be t squared, right? And then du is 2t dt, so we're going to be able to get the t's to cancel out. And then dt is going to be du over 2t. And then we do our subs. So get the integral of t all over u squared plus 25 times dt, which is du over 2t. You can factor out 1/2. The t's are going to say goodbye, goodbye, goodbye. And then we have our sort of template form of du all over u squared plus a squared, where a is clearly equal to 5. Okay, so just plugging and chugging then. 1 over a is 1/5 tan inverse of u all over a plus c. And that will be 1/5 tan inverse of t squared over 5 plus c. One small note on the inverse notation. Some people get confused and think that this -1 here is an exponent, but it's not. It's just symbol. So to avoid thinking that tan inverse is the same as 1 over tan, which it's not, you'll see in the book they write arctan. Okay, I'm not sure if that's why they write the arctan. It might have some other reason, but for us, I think it's, it's going to come up because you're going to see arctan in the book and in the software sometimes. So just be aware that arctan is the same thing as tan inverse, as well as arcsine is the same as sine inverse, and arcsecant is the same as secant inverse. Okay. Okay. Let's look at another one. So let's look at something a little more weird. Let's look at number 6. Okay. Numero 6. We have 1 all over 4 plus x minus 3 squared dx. Okay. So it has that form, but the u thing this time is not a single term, right? It's a binomial, and that's okay. You don't have to worry or overthink it. Just let u be the x minus 3, right? So then the du will be dx, and there's really not much else to do. So we have the integral of 1 all over 4 plus u squared. It looks like it's a arctan, or tan inverse, with a value equaling 2. So you'll have 1 over 2 tan inverse of u all over 2 plus c, and then you just back sub. Okay, so weird. All right, let's look at maybe something more complicated. How about something? Sorry. Let's look at number 12, I guess. Seems like a weird one. 12. You have the integral of 1 all over x times the square root of 1 minus ln of x squared. Yes. If you look back at the forms, this kind of looks like a secant, but it turns out it's not. It's a sine inverse. It's not a secant inverse, it's sine inverse. And it's because if you do the u sub, right? So you're looking for like a squared minus u squared. It looks like u is going to be the natural log of x. So if you let u equal ln of x, then your differential is 1 over x dx. And then, of course, dx can be rewritten as x du. So when you do your replacements, you'll get 1 over x square root of 1 minus u squared times dx, which is now x du, and you see that there's a cancellation, right? So it's no longer the kind of secant form, but rather it's an inverse sine form. Okay. So don't jump to any conclusions. Let the math tell you what to do. So 1 minus u squared du, and then that's going to have an a value of 1, so arcsine or sine inverse of u over 1 plus c, and then you could back sub, simplify, and you have your answer. Sine inverse of ln of x plus c. Okay, okay, great. Let's see if we can find an actual secant inverse in here somewhere. And Yeah, sure. So I guess there aren't a lot of these in the book. This is very upsetting for me. I guess I have no choice. Number 5. So this will be the integral of 1 over x times the square root of 4x squared minus 1 dx. So this one is definitely in that secant inverse form. You can kind of identify the u parts, square root, something squared minus a squared. A looks like it's going to be 1, and u looks like it's going to be 2x, right? So we need to rewrite everything in terms of u. U is 2x. The differential du is 2dx. And so dx is du over 2. You won't get the x in the denominator that cancels, so you need to kind of use this to solve for x in terms of u. So you'll end up getting x is u over 2. Okay, so we can do our subs. So I have the integral of, and I lost my dx somewhere, 1 all over x, which is now u over 2. 1 over u over 2 is really 2 over u, so let's put the 2 in the numerator. Square root of u squared minus 1, and then dx is du over 2. Okay. So it looks like the 2's will cancel, and we have our nice secant inverse form. A is going to be 1, and so it's 1 over 1, so just 1 times secant inverse of u over 1 plus c, and then that'll be secant inverse back subbing of 2x plus c. Okay. Now this should be absolute value, so sorry. Absolute value. If you don't put that in WebAssign, yeah, it's going to mark it wrong, so you need to put that in there. Okay. Let's look at some other ones. So there's weird ones like number 22, where you're going to need to rewrite it using kind of by bifurcating it, right? So I'll just rewriting the integrand. So just butterfly. So ways to rewrite your integral so it's an inverse, so it's clearly an inverse integral. So like number 22, we have the integral of 4x plus 3 all over the square root of 1 minus x squared dx. So it kind of looks like it has that sine inverse form. We're going to need the butterfly, right? So I'm going to rewrite it as the integral of this over this plus the integral of this over this and hope things work out for the best. Okay, so let's see that. So I have the integral of 4x all over the square root of 1 minus x squared dx plus the integral of 3 all over the square root of 1 minus x squared dx. The second one is clearly sine inverse with a value of 1. The first guy you're going to have to do a u sub on, right? So u is going to be 1 minus x squared, and then du negative 2x dx. So my dx is going to be negative du over 2x. Okay. So I rewrite my first integral, 4x all over the square root of u times negative du over 2x. And then my second integral, you can factor out the 3, of course, and you just have 1 all over the square root 1 minus x squared dx. You could let u be x, but it's a bit silly. They're dummy variables, so you can literally just write u as x if you want to, and then it's clearly in the form, but the variables are, you know. All right, so anyways, you can factor out a negative 2 when all is said and done, right? For some cancellation. So you can factor out negative 2 from the first integral. Rewrite 1 over square root u as u to the negative 1/2 du. This other integral is 3 sine inverse of u all over a. U is x, over a is 1. C. And then we need to do a power rule. So negative 2 times u now to the positive 1/2. Negative 1/2 plus 1 is 1/2 times the reciprocal of 1/2 is 2 plus 3 sine inverse of x plus c. And finally, negative 4 back subbing for u is 2x to the 1/2 plus 3 sine inverse of x plus c. Oh, sorry, my back sub was wrong. It's 1 minus x squared. Sorry. Okay, we'll make that the quiz problem. Quiz 2, video quiz 2 is going to be number 22. Let me just mark that down in my notes so I don't forget. 28, this number 22. I don't know what it really is in the book, but oops, you have to do that and put it on a piece of paper and include it with the 5.7 question, the 5.9 question, the 6.1. So you should have 4 problems from the videos written out. Okay, so that's one way you can kind of figure this out. Another way you can rewrite the integrand is by completing the square. Okay, so completing the square. And let's take a look at WebAssign and get the problem. There's a problem in there that we can look at. Am I recording? Yeah, oh, thank gosh. All right, so look at number 10. And that should be instructive, somewhat instructive maybe. Okay, so number 10, we have the integral from 2 to the 3 of 2x minus 3 all over the square root of 4x minus x squared dx. Okay, so completing the square in the denominator. How is that done? So if you have something like x squared plus bx and you want it to turn it into something you could factor into x plus whatever times x plus whatever, or x minus whatever, x minus whatever, what you're going to do is add in and then immediately subtract b all over 2. Okay. And that will complete the square. So what is the b over 2 in this picture? So let me rewrite the integral. Integral from 2 to the 3, 2x minus 3 all over. You need to have x squared plus bx. So I'm going to factor out a negative. So I'll have x squared minus 4x. So b is negative 4. And then I have to add something in and then immediately subtract it. Okay. The weird thing is I'm going to be subtracting it on the outside of this. I didn't have enough room on my square root symbol. Okay, so I'm going to add it in and then immediately subtract it. But because there's a negative on the outside now of these parentheses, in order to get it to actually be the sort of inverse operation, I need to, instead of subtracting, add. Okay. And then we have completed the square. So let's see what that number is, first off. So b over 2, in this case, negative 4 all over 2, which is negative 2. And then we need to square it. Okay, so I forgot to put little squares in there. So this thing squared is 4. So I need the plus 4 here. But really what you're doing is minusing a 4. So to undo that, you need to add a 4 in over here. Okay? Okay, so you can look up videos on completing the square if you don't remember how to do that. Let's see what we got. So I have the integral from 2 to the 3 of 2x minus 3 all over, and rewriting a bit, I have the square root of 4 minus x minus 2 squared. And now, at least that denominator, is going to be kind of our sine inverse. We're still going to have some more work to do, right? Because we have to, on top of everything else, butterfly. So I need to turn this into 2 integrals. Hopefully not forget I have to evaluate at the end. So we have 2x all over the square root of 4 minus x minus 2 squared, and then dx minus the integral of 3 all over the square root of 4 minus x minus 2 squared dx. Okay, the first one I'm going to have a lot more work. I'm going to have to probably scooch over here. It's snowballing, and see what happens. Okay. Okay. So on the first integral, I'm going to do a u sub for 4 minus x minus 2 squared. Believe it or not. So du, the derivative of 4 is 0, and then the derivative I have to do a power rule. So negative 2 times x minus 2 dx. And then I can divide both sides. So dx is going to be negative du all over 2 times x minus 2. Okay. So it's literally 2x minus 4 if you want it to distribute. And maybe that'll help you kind of see how you're going to make this work. Because as is, you're not going to get that cancellation, right? You're going to have a weird sort of awkward expression. So how do I fix that? What you're going to do is this trick. So I'm going to minus 4 and then immediately add 4, believe it or not. So it's pretty weird, isn't it? It's all over the square root of u. And then times this negative du all over 2x minus 4. Okay. And then minus the integral of, and that's not going to work. That's going to be real bad news. So even before then, you're going, yeah, so sorry, this is a lot more complicated than I thought. Even before you get to this step, I mean, even this trick won't fix it, right? You're still not going to get that cancellation. So before you even do your u sub, because you see you're having this issue, you want to go ahead and do the trick. So you're going to have 2x. You want to go minus 4 plus 4 all over the square root of 4 minus x minus 2 squared. I apologize, this is really snowballing now. Minus the integral of, don't worry, I'm not going to put this one on the test, 3 all over square root of 4 minus x minus 2 squared dx. You can then bifurcate or butterfly this thing to get that cancellation when you do a u sub, and then this other part is just going, you can add that in to this integral over here. Okay, so let's see that. So I have the integral of 2x minus 4 all over the square root of 4 minus x minus 2 squared dx. And I'll be able to do that u sub I have right above it. And then plus the integral of 4 all over the square root of 4 minus x minus 2 squared dx. And then minus the integral of 3 all over 4 minus x minus 2 squared square root of dx. And you see these two integrals are like terms, so you can combine those. And then also we're doing the u sub on the first integral. So the first integral will be the integral of 2x minus 4 all over the square root of u times negative du over 2x minus 4. And then plus the integral of 1 all over the square root of 4 minus x minus 2 squared dx. The first integral of 2x minus 4's will cancel. I'll rewrite the integral as u to the negative 1/2. And we have a negative floating around as well, du. On the second integral, you may want to do a u sub or some version of a u sub, a z sub. Z is x minus 2, just to make it look familiar. dz is just dx. Okay. So you put it into one of our forms. So you get 1 all over the square root of 4 minus u squared du, or dz, sorry, I did a z sub. So dz. So the first integral, we have negative u now, so negative 1/2 plus 1 is 1/2 times the reciprocal of 1/2 is 2. Plus, and our a value is 2 for this inverse sine, so 1 so we don't need to put the coefficient in front. So just sine inverse of z all over 2, and then we need to evaluate it eventually when we do our back subs. So I get negative 2 times the square root of u, whatever u was. So u was that 4 minus x minus 2 squared. And then plus arc sine of z, which is x minus 2 all over 2, and we need to evaluate, right? So we're evaluating from 2 to 3. Okay, so if you plug in 3, you'll have negative 2 times the square root of 4 minus 3 minus 2 is 1. 1 squared is 1, so just 4 minus 1, plus sine inverse of 3 minus 2 is 1 all over 2, so 1/2. And then plug in 2 to the antiderivative. You'll have negative 2 times the square root of 4 minus 2 minus 2 is 0. 0 squared is 0. Plus sine inverse of 2 minus 2 over 2 is 0. So we'll have negative 2 root 3 plus sine inverse of 1/2 plus 2 times root 4, which is just 2, minus sine inverse of 0. Sine inverse of 0 is just 0. So we'll end up with negative 2 root 3 plus 4 plus sine inverse of 1/2. Okay. So that was a mouthful. Really took me for a loop. Let's make sure we got the right answer, right? So let's go to the old. Actually, I like to just go the Wolfram alpha. And what do we have? We have negative 2 squirt of 3 plus 4 plus arc sine of 1/2. And I'm getting 1.05 or 0.59er. And yeah, 1.059. So we got it. Just took a little while. So that was longer than I wanted to take, but there it is. Good stuff, right? So yeah, let's leave it at that. That was enough of a nightmare. Looks like there's another complete the square, number 11. Jeez. And yeah, okay. So let's call it quits for this video, and we'll see you next time.